Negri, also from the São Paulo State University in Brazil. So this research was funded by the São Paulo State Foundation, the FAPESP, and by the Brazilian Research Foundations, CNPq, and CAPES. All right, and today we are talking about the image segmentation, about our paper about image segmentation problem. So this presentation is organized as follows. First, we will introduce and motivate the problem as well, the contributions, and the next step to discuss here. And we also take about the methodology, the methods, and the models we adapted here to perform our analysis, the experimental results, conclusion, and finally the acknowledgements. All right, so this paper is about the image segmentation problem. It's a well-known problem. So here we focus on studying a specific problem in the image segmentation field. It's the seeded image segmentation or the interactive image segmentation. So the goal here is to extract the object from the image background. We can so here we have an example of this kind of approach working. So we got the image, and the goal here is to extract the object from the image background in order to get binary mask. Once we have the binary mask, we can extract the object from the image by cropping the image. So like this, the right image here. In order to do so, we focus on studying three kind of approaches. So we take the energy minimization problems, solve it on image derived graphs. We also employed interactive segmentation, I mean the seeded image segmentation mechanisms. And finally, we also consider taking deep learning strategies in order to improve the segmentation accuracy. So here we can see an example of this kind of approach working. So we have an image with the scribbles, provided by the user. I mean, this is the seeded pixels as given by the user. Once we have both information, the image and the scribbles, we can get the final segmentation. So here, all these images were obtained by applying our approach. So before going deeper into the image segmentation problem, it's important to know about what are the main drawbacks in this kind of field. So here we list some of them. So example, seeded image segmentation, they are highly sensitive to the parameters tuning. So we have to tune the parameters in some way. And the second issue is that the need for specific data collections for training purposes are another issue that users should be facing in order to run in the approach in many practical applications. And finally, this kind of methodologies, these methods, they usually produce segmentations with low adherence with respect to the image boundaries, resulting in low quality segmentation outputs. So here we can see an example of the issue number 3, where we have the original given image and the seeds provided by the user. In image B, C, and D, we can see some examples as provided, as computed by classic seeded image segmentation methods. So we can see here the power watershed result, the maximum spanning forest, and the Rondo-Walker methods as run in this image, and we can see that those methods they may fail in properly capture the image boundaries. So here the goal in our contributions were the following. we combine three different kind of approaches. So we take deep learning networks, and more specifically, we apply a deep convolutional neural network in order to get some boundaries from the image. So we also consider taking the seeded image segmentation tools, and finally we also take label propagation models. I mean, more specifically, diffusion maps. So this leads to the resolution on an energy minimization problem on an image derivative graph, and essentially the methodology that we built, it learns graph edge weights from the graphs as constructed from the image. This is the proposed learning framework we adopted. So basically, in the step number one, we take the input image, the original image, and we apply CNN. Is basically a counter orientation mapping network that extract the image boundaries, like these two images here, the x-axis and y-axis oriented boundary maps. So by doing so, this is we just take some a specific convolution neural network. So more specifically, we get the deep image boundaries by applying the club architecture, the convolution-oriented boundary. So the goal here is to obtain some different kind of multi-scale boundaries representations from the image, like final details and coarse details, and put this information together in order to get some refined result for representing the image boundaries, all right? Once we have computed both the x-axis and y-axis deep boundary maps, we apply a label propagation model. So we basically take the label diffusion model together with the seeds as provided by the user and put this information together in order to compute diffusion maps. So in more mathematical words, we build a simple but very effective image graph. So we take the stencil like a cross. It's very simple, but it's very effective in terms of computing the boundaries and other relevant informations from the image, from patterns from the image. So once we have defined the graph from the input image, we just apply a label propagation model. And in particular, in this paper, we consider the Randall-Walker energy function. It's basically taking into account the difference between xy and xj pixels. And the seeded, as given by the user, is represented by the xd equals to 0 and xf equals to 1, just to represent the background seed and the foreground seeds. So then we minimize the Randall-Walker energy function. In order to properly minimize this kind of function, we need to expand this equation in matrix form. So by doing this, we get a matrix form to represent the Randall-Walker energy function. So the minimization is performed just by getting the differentiate from the energy function with respect to the xu vector. And we get, by doing so, the definitive a system of linear equation more specifically, I mean, a sparse system of linear equation. Once we have defined, we have computed the minimization and this sparse system linear of equations, we finally get the diffusion maps, like this representation here. So we combine both informations, the diffusion maps given by the label diffusion model as computed in the previous slide. So with the ground truth information in order to compute the loss function. Here in our approach, we consider the loss function as the cross entropy error. So basically, this metric measures the dissimilarities between the diffusion maps and the ground truth maps. And finally, once we have computed the loss function and the backpropagation is also completed, so the approach returns to the beginning of the interactive process, and this is performed in in an interactive way. All right, so in order to check the results, the results and the comparisons, we take some data sets and evaluation metrics in order to properly access those results. So in terms of data sets, we take the Gradcode data set and the Berkeley image segmentation data sets. Both data sets are very popular data sets in the image segmentation field. And we train our model by taking the Joestar data set. It's another well-known and popular, well-established data set to train our model. Once the model is built, we can check, we can assess the results as provided by the method, right? So here we take 4 evaluation metrics, the validation metrics, and that we consider are the following: F1, rank index, variation of information, and boundary displacement error. In terms of the methods we compare, we take both state-of-the-art algorithms as well as the percent approach. So here we can see some examples that we obtain by applying our approach and the other methods, segmentation methods. So we can see that the design method can produce very accurate results, like the Llama image here. You can see there's some difference in terms of image boundaries captured. But in terms of quantitative assessments, we also analyze our approach against others. So we can see here some of the metrics as computed by the results. We can see that F1, RI, and the BDE give the best scores for the proposed approach, except for the variation of information, which where the one-cut approach gives the best result. So here we can see some examples as computed by the proposed approach and by other algorithms, F-score and rank index. The same for the remaining evaluation metrics. And we can see that the proposed approach results in more stable results, especially for the BDE and the last 2 metrics, the F-score and the rank index. All right, as conclusion of our work, we built an image segmentation approach that produce high-quality segmentations with smooth boundaries. The learning for label propagation with the Wonder-Walker energy function as adopted in this paper was capable of providing high adherence image boundaries. And the label propagation model also ensures, it's a very important, the uniqueness of solution while resulting in a sparse system of linear equation to be computed. Better performance compared to existing segmentation methods in terms of accuracy and object detection. As future work, we are planning to evaluate the other label diffusion models to improve, in order to improve the object discrimination. And finally, to deal with other practical applications, including remote sensing applications, where segmentation is critical. Okay, thank you very much for your attention.
Thank you all. We have time for a few questions. Beyond that? No. Any questions? Then, as a chair, I have the obligation to fill with a lot of questions. Can you go back to the main diagram of your
Of course.
approach? That's any one of these versions. So I understand that the x-axis and the y-axis boundaries are not user-dependent. You're just going to get the image, do the control detection, then you're going to apply the seeds.
No, actually, the seeds we apply here.
But after the
No, we don't consider the seeds from this in this step here.
Okay.
We just put the seeds only in this step.
So if for some reason we work at the remote sensing and mislabeling is a huge issue. So sometimes somebody just put a wrong label and the whole classification result is bad. So in this approach, I can just fix the seeds and I don't need to run the first step again, just from that label diffusion on. Do you have any idea on the time, how computationally heavy is this process?
If we consider the seeds?
No, for the whole process.
Okay. To train the model, it takes some minutes. It's not so huge, the computational time. So we can just take some 20 minutes, something like that. Of course, it depends on the machine we are running, but by consider just our notebook, we took 20 minutes to train
using a notebook.
The definitive model.
The next question is, what if I have a problem that's not foreground and background?
Yes, we can deal with this kind of approach. In this case, let me see. We can apply this kind of approach by using multiple seeds. So we didn't try it, but for the other papers we tried it and it works.
Okay.
So here we can. I think it's possible to input this kind of multiple information.
Okay. We'll get a copy of the paper later when the proceedings, and I
Sure.
get back to you. Any further questions? No. Then thanks again, Alison.
Thank you.
And I'd like to go back to the order of the presentation that Dr. Duarte is here. So we can go back to the first presentation.
First of all, I'm sorry for the exchange, the chair and the participants, but my taxi left me 3 kilometers ago from here, and I had my jogging in the morning, so I'm sorry for my look also.
The map wasn't precise about the building, so
No, it
you
wasn't.
also went on the other back.
Yeah, you also.
But had a guide, so it was. Oh, welcome to Greece, and you're from Portugal, right?
Yeah.
No,
Yeah.
where from Portugal?
Brazil, center,
The center.
yeah, near Porto.
Not as hot as that.
No, not as hot. Not now. In the mid August, 40 degrees is not as hot.
Okay, usually the presentation is around 15 minutes, and we have some time. But I usually get, when you have 2 minutes left, I start with suggestions. Just that,
So you can open your presentation
Why not?
and then share it with the answer.
It's PowerPoint.
Because I see that we have no audience or not. How can
We
we
have
see?
here.
Yes, here we have. But perhaps you have not to share it.
But if you cannot open because it doesn't have PowerPoint. Or I can make another copy.
Okay. We have an audience, so you have to share your presentation. Okay.
Just watch out for the network cable is a little bit.
No, okay, okay. Okay, so where is it? Oh, you had it on the desktop already.
That's never mind.
Okay.
It's this one.
Dr. Zua's presentation is automatic user testing and emotion detection in interactive urban devices.
Oops.
And you must.
Just this is it's in Greek. I don't. I just click on the X.
You must no. You must.
The button.
I must press this button.
Yes.
Okay. And then
I'm going to ask you a lot of questions in Greek.
oh, and now
Okay. Okay.
it's not appearing here. There's some box here, maybe. I don't know.
So the problem is.
Maybe on Windows, if you try to duplicate the screen or expand. From Bristol. That's why I'm not expecting it. You should also have to weather like this. Okay, great. So thank you again.
Please go ahead.
Again, sir? Okay, thank you. Okay, so this work basically.
Have you shared your
What?
your screen with our audience, the virtual audience?
I don't know.
With the GC? Sorry, go again?
If he has shared his screen with our virtual audience. We have.
You share the screen in the computer?
Yeah, that
Yes.
was preparado.
Eu já usei isso.
Incrível.
Por isso que é bom o ícone, né?
Pelo menos isso, eles fizeram gentileza.
Automatic user. Is this your presentation?
That's one.
Okay. Now you are ready. Okay.
Yeah, we go back now.
Let's just. Okay. So this paper focuses on two aspects that we work in the computer vision and human behavior group in Portugal. It has to do with emotions. Last time we worked with emotions, we tried to detect human perception and human testing on how they feel when looking at products in shopping centers and to see if they were lost or if they found the product for intervention. So that's the last work we did on emotion detection. And interaction is one of the key works we usually work trying to make new approaches to interface design. In this case, we tried to, with a company, we tried to work with urban devices, the touchable urban devices, usually and typically made available on cities, on the context of smart cities. So we try to merge these two fields to try to test if an interface and how the interface is usable, and this can be achieved by measuring emotions of users. So we have different types of emotions as humans, right? And we have computer systems and machine learning algorithms to detect them. In this paper, we use three approaches just to show that to categorize emotions is better than to use the emotion itself, because machine learning algorithms fail a lot and we need accuracy in the detection of the type of emotion. And of course, user interaction is one of the key aspects to measure quality of interfaces and to test if the tasks are done as easily as they could be done for users. Previous work falls into 4, 5, 6 categories. The most relevant are emotion detection, interaction, and smart cities. This is the broad context. In the context of this work, we work with facial recognition, emotion detection, human detection to detect humans on the interaction, and some works of digital authors, also called as Muppets. So the general idea is to gather emotions using a camera to detect interactions and get information from the touch. We need to have this information on the screen, X, Y positions. Then we store all this information in a database, and then we process this in a visualizer. This visualizer basically contains colors. Colors are related to emotions. Emotions are associated to steps in the interaction for each of the values that we obtain for different parameters that are stored in the database. The idea is to generate this visualizer to understand where are the red dots in the interaction. So, just a small view of data gathering and emotion. Facial recognition basically has three aspects: negative emotions, positive emotions, and neutral emotions. We classified them into three types: negative, positive, and neutral emotions. We will show we use three data sets just to show that we really cannot say 100% that emotions that are detected with machine learning are correct emotions. So one of the data sets was the DeepFace API. Basically, we focus on the last three columns that were created. So we have a real emotion that a user had. We have the emotion generated from the API, and in bold, not visible here, but when we see send sphere, this is kind of cool. sadness here, so it's a different emotion. And what we see is that we have different real emotions than the one that was generated from an API using this data set. But we also classify them positive, negative, and neutral emotions that we want to have this as 100%. Since we saw, and we will see here, that we don't get 100% on the real versus API. However, here we don't have yet 100%. When we use another dataset from Keras API with FAIR and AffectNet, it's another dataset for emotions, image extraction of emotions, of course. We still don't have 100% of emotion value, but with the Keras API with FAIR, we get this 100%, and we still don't get 100% here. We have two situations here. We have other situations that don't occur, but on the last column, that's what we want to achieve: 100% of effectiveness. Summing up, what we have was well positioned in my presentation. So what we have here is with Keras, we have 100% in the context of these two columns, the real emotion and the API emotion. But when we go to the three emotion categories, positive, negative, and neutral, we have 100%. So from the emotion side, we say that we have a baseline for accurate emotion classification, because we don't want red dots where there should be green dots. Okay. So this is the first part. The second part has to do with interaction and the system. System is called the Tommies. They're positioned in several cities, from Portugal, Chile, Brazil, Europe, also some cities in Europe. It's from a company that uses this in the context of smart cities. They provide services for users to look for restaurants, to look for places to stay. It's not like a mobile phone in an outdoor mapping, an interactive outdoor mapping. So the baseline for us is that users carry out actions on this interface. And by carrying out their actions, doing their tasks, we gather a sequence of information that is stored in the database. This is of most importance for us to try to measure where the interaction failed, because we don't use the recording cameras. We don't use eye gazes we could use, but we don't use eye gazes to detect where the users look at. So what we do, we store a lot of information. I will talk a little bit more about what's this information that we stored in the database. But basically, it has to do with the position on the interface that the user interacted, where he has clicked, what's his goal, because he needs to have a goal to reach for the interaction to terminate, to finish. And then we bring the emotion and we put it here from the previous step. Basically, the two algorithms in a simple way are as follows. So we detect a person, we detect his face, we get his face, from his face we get his emotions, then we process the three categories of negative, positive, and neutral emotion. The most prevalent emotion, obviously, is the max value of all these three emotions. With this, we have, with the 100% accuracy that we have achieved with the dataset, we have the emotion that we need to put in these columns, but now we need all the rest. So once we get all the rest, we go to the Tommy author, we get his interaction, user interaction. For each interaction, we store it in the database, and we have this is not beautiful, but it's okay. I cannot do anything now because it's in my computer. We have the touch panel, XY is the position, then we have the topic menu slug. It's the category of the objects the user has interacted. We have the get date. The get date has to do with the value of the API emotion detection. So at one point where I'm clicking, I have an emotion. I need to have the date and time. The date has and the time also of this interaction for me to put it in the column, the correct position of the interaction that the user had with this object. And then we go level. We have a category. Okay, it has to do, for example, with transportation. The transportation is in a filter. The filter, I have an action in a certain place, in an object is where to hit, for example. And then I have the objective. I need to reach a goal in my interaction. When I reach a goal, and my goal is reached when I concatenate this, and I get this string. And if there's a match in the string, then I get the goal I was looking for. A real test scenario that we did on the streets with Atomic. Basically, we have more information on the paper related to the subtasks. They are detailed in the paper. But what we have is basically 3 goals. We define the user 3 goals to reach: to find the location of a restaurant in the context where he was working or living, to promote himself in social networks by taking a photo, sharing something with his friends, because the software allows them to do it. And okay, now you don't have anything to do in the city, work, so enjoy your afternoon, find something to do in the afternoon. What we had as results of interaction with users was that, on average, the users had to reach a goal, they took more than the required interaction that was needed. They overlapped the 100% that was required. On average, they had 124% of more interactions than the required. Moreover, we have 74.24% of neutral and negative emotions. We don't want these emotions. Naturally, we can deal with them, but we want everyone to be happy. So we were focusing on positive emotions of interaction. So the result is that only approximately 25% of the interactions were, in fact, positive interactions. The result is that, okay, so this is general view, but we want to give the design team and the guys that work on on interaction and for them to improve interaction. What we have is, for each of the parameters that we have on the database, we don't need all this information, but we ended up summing it because we can analyze it by metaslug and the concatenation of the goal. This is all the concatenation of the goal. It's very small, but it's a concatenation where I need my goal, I reach my goal, or I don't reach my goal. Everyone has reached the goal, but with many times a lot of more interactions to reach the goal, that basically the optimal goal was reached here in this interaction, the black dot. So what we have, and we can see, is that there are certain areas where most users have most difficulties on interaction. And this was given back to the design team for them to improve the design of the system. Of course, this is a production system, and this work was terminated a while, not too long ago, so results are not yet implemented of this, but they understood that for these interactions, for example, one of the difficulties did not have, some of the difficulties had to do with the positioning of the users in the system, because Atomic is a big object. For them to interact, they need to move their hands a lot to make interactions. And these tires users, and they need some objects to be closer to each other for the interaction to be smaller. So this was one of the conclusions they took from this, that they thought that basically it passed a lot of human testing on controlled laboratory experiments, because with a mouse it's easier to make these interactions. They passed heuristic evaluation, Nielsen's heuristics, user experience, the questionnaires, a lot of tests that were made. They passed, but with this system of measuring emotions while interacting, some of the improvements were made to the interface. We also chose to, since we were doing this visualizer, we also choose to explore all the information. For example, in the categories, photo, agenda, the first chart, we have information about how for each category the users interact with the component itself in a broader view of the component, because we have that information on the database. Okay, so basically what we have developed is basically a method that allows us to analyze emotion and detect usability problems of user interaction. We gather emotion and we put them using a facial recognition system, and we use interaction recorder, basically stored in the database of interactions. We have an overlapping timeline into a visualizer, and the method is of course suitable for real scenarios. We haven't tested it on other interfaces, but we believe that it will also work well. Future work, improve the visualizer. When we have overlapping, we haven't solved it yet, but when we have overlapping with colors, of course, we have red, green, yellow.
it's complicated to put all the three colors together. And we could create another color, but then it would be a lot of colors. We need to use basically three colors to try to improve the interaction and improve the labels of the XY axis. But basically, it's this. Work is done, and people like it. So thank you all for watching.
Thank you. Questions? Questions? Okay, I always have two questions. First one is that you choose to do that for the design proposal. So we're going to measure the
Emotion,
sentiments and see if they are angry or if they are happy with the interactions. But did you consider that using that for mental health purposes? Because there's some places that I think there are some places, I'm not sure if Japan, they are monitoring to see
a lot
if people
of,
are getting.
yeah, a lot of places. Even we could use other aspects like facial landmarks. That's the position of our eyes. If you look down, up, side, and that's another way we could with that. But the problem is to get XY positions of interaction. The background need to implement that based on eye gazing and looking at the interface. But on fall detection, for example, when people fall, the movement of the body and the positioning of the face, it has a lot of applications. On health, we have other projects, health issues, but not related to this and emotion.
So which features you are using for the happiness and the sadness? Marks? Landmarks,
no, the face landmark. We have positioning. It's basically the machine learning algorithm does it in the black box. So you just give them the images, the process, give the input image, and it processes the image with one of these data sets. But basically, what they do, they extract the positioning here on the mouth, near the mouth, and I think some of these and here to extract the emotion.
You did a test with 77 users, but they knew that they were being tested.
Yeah, they knew that we were being
tested. Did you do any kind of test with?
No, because that's an issue with protection. We cannot. It's the problem of facial recognition. We can show that it can be used, and it's good, it's important, but to everyone that enters somewhere to give a consent form for something that deals with privacy and security, it's very complicated.
You cannot do a real test on real field because people will know that they're being tested.
We can do it with a consent form that people consent, that we have some authority saying that this data does not interfere. But the truth is that it does not interfere with people's life because a person is a picture ID and it doesn't have to do with the person. So there's no correlation between one image of me, except if you know me, like if my picture, that set of pixels says it's dwarfed, right? It doesn't say it's dwarfed, it's just a set of pixels.
Okay. Thank you very much again.
Thank you.
And for the next presentation, that's Miss Bianca Rosin. It's going to present semi-supervised time series classification through image representations. Can we see your set here?
Ixi, cadê o negócio, gente? Como que sai?
Can you take it? Yes. Okay.
Try alt tab.
Okay. So. Okay, go ahead.
So,
Go ahead, John.
good morning, everyone. I'm going to be presenting the semi-supervised time series classification through image representations paper. Okay, it was developed by me, Sir Emilio Bergamin, teacher, Professor Daniel Pedronetti, and Professor Fabrício Brevi. We're all from UNESCO Rio Claro. Okay. First of all, time series. There are elements that consists in measures that of a variable that varies over the time. Okay, so stock prices are examples of time series. Echocardiograms are example of time series. Sensor data and another stuff can be interpreted as time series, and it's interesting and very important to analyze it. More specifically, time series classification allows human activity recognition, disease monitoring, and phenology studies as examples that we can use the time series classification. The state-of-art method actually is the Hive code, which is an ensemble of lots of classifiers that perform, and then it's performed a statistical analysis to set up the final label to each point of a data set. The limitations are the amount of time to perform this classification and also the amount of labeled data, okay? Because it is expensive and time consuming to label data. And traditional classifiers, also deep learning classifiers, needs a lot of labeled data to work. So our proposal is to use semi-supervised classification in time series. This means that we use both labeled and unlabeled data to perform the classification. So we need less labeled data to achieve similar results, okay? So I forgot something here. We're also using an approach that we first image a time series and then we perform the feature extraction. Okay, I will explain it better later. First of all, I'm going to talk about this supervised approach. We have a situation that the amount of labeled data is way smaller than the unlabeled data. And we're performing here a semi-supervised classifier that is graph-based and uses label propagation. We first start computing the Gaussian similarity, considering the Euclidean distance. And then we perform the sparsification procedure. So a node will be connected only to its k nearest neighbors. And the k nearest neighbors in this case will be the log base 2 of the size of the data set. So we don't have, we will have it should be nodes of the same class connected only, okay? We also have the delta parameter for the Gaussian similarity. Usually it's used like this in the literature, so we use the same way. As I said, edges should connect nodes of same classes, and this assures the clustering hypothesis, where nodes of that belongs to a same cluster should belong to the same class. Because in semi-supervised learning, clustering and classification are very correlated. Then we perform the label propagation using Gaussian random fields. Okay. We have to minimize this cost function based on the similarities, and the probability of a node belonging to a class. The minimization is then performed considering the number. Just a second, please. This is already called the number of label points. Okay, so if we have an element that is less or equal than the number of labeled points, we set up the probabilities as this. It's quite simple. We also perform iterations where each probability is updated considering some values from the neighbors in the previous iteration. And then this value is normalized as it is in this function here. So in order to not iteration up to the end of the times, we set up this parameter Tmax, and which is the maximum number of the iterations, or an upper bound, which is a difference between each iteration. Okay, and after convergence, if we still have an unknown label of an element, we do not perform this to label it. It's quite simple. Well, for time series feature extraction, we have many approaches. We have shape-based approaches. We have kernel-based approaches, bag-of-word approaches. We still don't have a deep learning method. In images, we have a well-known method that is usually it is a convolutional neural network pre-trained with the ImageNet dataset. And this network is used for feature extraction. So we are using this to perform feature extraction in time series. We first image the time series and then we extract the features. So we are using these three methods, okay? We're using gram and angular fields, which is based on polar, transforming the time series in polar coordinates. Markov transition fields, that is based on the probability of transitions between points of the time series. And the recurrence plots, which is based on the trajectory of the time series. So then we are using the CNN ResNet to extract the features, and also vision transformers to perform a feature extraction. Both pre-trained with the ImageNet dataset. Well, to perform the classification, we are using 4 datasets from the UCR archive. Okay. We chose them based on the size, the domain, the size of the time series, and also the size of the dataset itself, and also the number of classes. So we have a synthetic generated dataset, which is the CBF. We have the ECG 5000, which is an ECG dataset from a patient with congestive heart failure. We have the yoga dataset, which is a human activity recognition-based dataset, and the electric devices dataset, which is the biggest one. It's very big. And it's based on classifying devices based on its daily power consumption. So we perform this experimental setup. We first image time series using the PyTS library from Python. Okay, we use it. We didn't change any parameters. And then we perform the feature extraction using deep learning. We also compare these obtained features with the unprocessed data. Then we build the graph and we perform the label propagation step. We set up the parameters for the iteration as 1,000 iterations, and our epsilon is 10 up to -3. We perform a kind of cross-validation setup also, which is based on splitting up the data set in different sizes of labeled and unlabeled data. And the unlabeled one should always have an element of each class, okay? And the reported results are the average of equally sized splits, of 10 equally sized splits, to be more specific. We also perform an evaluation of the K value, considering 2% of the labeled, of the data set being labeled. We report the results of the accuracy, which is a very common metric for classification, and adjusted mutual information, which is a clustering classification. So we can observe the relationship between clustering and classification. We compare the results with baselines, okay, with the state-of-art results, and we also perform, okay, statistical analysis. So, beginning with the electric devices dataset, we have code results. This is another classifier here. We can observe that the baseline, supervised baselines, uses more than half of the dataset as labeled. And here we obtain very competitive results with less than 20% of the dataset. We also can observe that raw data performs poorly, worse. CBF dataset, we can observe that the supervised baseline uses 3% of the data to reach these results. And we can observe that we reach the same results using 6% of the data. But using the same amount of data, we obtain competitive results, but not the same results as the state of art. ECG dataset, we can observe that the supervised baselines uses 10% of the data, and we obtain very competitive results using only 2.5% of the data. Yoga dataset was the worst one. We needed more than the double of the labeled amount of data to reach the state-of-art results, which is very poor results. We can observe that accuracy and AMI has similar curves, which shows the clustering and classification connection. We can observe that in general, raw data provides the best results, which may significate some Gaussian properties from the datasets. This doesn't happen in the electric devices dataset. And also we can observe that MTF features tend to be less accurate. We also perform a K evaluation here with a fixed size of labeled data. We can observe that K tends to reach a plateau, okay. And also our choose to pick up K as log base 2 of the size of the dataset seems to be a good choice, which is in the middle of the plateau, because K defines the complexity of the algorithm and also the accuracy. The statistical analysis here, well, we didn't analyze the electric device data set because it was huge and we didn't have computational effort to process it. We can observe that the vision transformers produces smaller pairwise distances. And we also can observe that the most accurate methods are has double peaked distribution, as we can see here. The combination of imaging, our feature extraction proposal tends to smooth
Yang mana,
the
Mbak?
distribution.
Mbak, tak mematikan anu, Mbak.
Excuse me. Also, observing the coefficient of variation of the similarities, we can observe that on CDF raw data it has the lowest variation. Okay, MTF has the lower variation for yoga, and MTF was also the worst as it was constated. And we can observe that in the kernel densities, MTF approaches have only a single peak distribution, which may mean that the classes are undistinguishable in these cases. So we can conclude that our method is suitable for the semi-supervised classification problem. We also can conclude that imaging methods are most impactful than the neural networks chosen. We intend to study why raw data performed better in most of the data sets, and this rule didn't work in the electric devices data set. We also intend to study some characteristics showed by the statistical analysis. Okay. Well, we are thankful to OPA, to FAPESP, CAPES, CNPq, and Prisma Labs for the infrastructure. Okay. Thank you.
Thank you. We have time for some quick questions.
I have a question. First of all, congratulations. It's a really nice, interesting paper.
Thank you.
So, did you guys try another labor propagation model?
No, not yet. We didn't have time, to be honest.
Okay.
But it's a possible future work.
Yeah.
Okay. Any other questions? I have a very good question.
Okay.
Some of these time series are very, it's hard to train. They are not noisy. For example, if you get an ECG, it's a flat, bound, flat, more or less like that. So that's a lot of nothing being measured sometimes. So comparing these two, it's a question of comparing just the differences. If you have a time series for solar emissions, for example, there are nothing, and then something happens, and then nothing, a long time of nothing. If you have, for example, rain patterns, it's not raining, then it starts raining, then it stops raining, then it starts raining. So that's a lot of time series that they have, nothing happens, and then something happens. It's just a way to do that. Do you think that not the CBF, because it's a lot of noise on that, but the other patterns are like that, this time series are like, so the results are more or less similar? Is that anything related to the nature of what's being measured? For example, if you get time series of the market, anything on the markets all the time, so it grows and that there's a word for that. I can't remember that. That's several time information overlapping on some time series, and some of them are just nothing, something happens, nothing, something happens. Do you see any difference on those for the approach? Because those three graphics that you use to compare them are going to be very different, especially I think the last one.
Well, I think these characteristics you cited are makes the difference. Though, because we also have different approaches for different domains, so it is. You're right.
Okay, so different domains you have.
Yes, there are specific methods for different domains.
Okay.
We're trying a general one here.
Okay. Thank you very much. Once again. I need your help because we have a 2 sheets to present. So the next two ones.
Here, Marcio Rosino.
And the other one is, this is,
IF.
do you get the names?
We cannot see.
Okay.
It's IF.
So Márcio is probably.
My father.
Esse é o Márcio do Brasil, tudo bem?
Isal firma.
Isai. So, do we have people that are watching us through Jitsi? Do we have Rauzan Sumara or Ivan Lufti Iwani?
Yeah, I will present for our people.
Can you close the camera from here? Because their parents are very proud. Yeah, but I think the other one. A sua sorte é que eles não estão trazendo só fotos de bebê, mostrando o cachorrinho levantando o cachorro. Every time, so this is very fun. I don't think they are here. I'm going to call them again. Okay, that's one of them.
Okay.
What is it?
It's okay.
One of them is there.
Yes.
Yes. Rauzan Sumara, can you open your video feed?
Okay.
Okay, Rauzan, can you hear us? Can you hear us?
Yeah, I can hear you.
Okay, the sound is a little bit low. Let me try to fix that. I haven't. Can you share a presentation with us, please?
Sure. Wait a second.
Go ahead, if you can share the presentation, share the screen. Yes.
All right. Can you see the screen?
This is going to be quiet. Okay, Mr. Sumara, you have to speak really, really loud.
Really?
But you can go ahead and present.
Okay. So, good morning, everyone. I hope everybody there is able to hear me from here. So today I'm going to present our research topic about Siamese network with the Gabor filter for recognizing handwritten digits. All right. Maybe I can check its sound. Is it hearable here? You can hear me, right?
Yeah, the sound is very. Oh, maybe this kind of thing. Okay, go again.
Check.
Yes, much better.
Much better. Okay.
Yes. So
Right.
the presentation is a Siamese network with Gabor filter for recognizing handwritten digits by Rauzan Sumara of the Warsaw University of Technology. Please go ahead. You have around 15 minutes for the presentation.
Okay, thank you very much. So let's go ahead to the introduction or agenda that we're going to talk about here. So first, maybe I will talk a little bit about the introduction, and next will be the method that we have conducted, and then third one will be explain about the experiment setup, the result, and then the last one will be conclusion and future work. So to be honest, if you talk about the digit recognitions on handwritten digits, we know that recently handwritten digit recognition is still one of the most interesting issue, right? And it's also one of the challenging issue because of each person has the unique written and pattern in terms of the way they write. Many methods have been conducted in terms of classification itself. So there's many paper has been evaluated by us. It's explained detail in our paper. It's like, let's say Um, they are using machine learning, deep learning, for example, and also hybrid methods and so on. There's many methods have been conducted recently. Uh, but however, there's many um, things that we can improve in terms of accuracy itself. For example, in deep learning, people may use the ResNet, AlexNet, PGG16, or maybe the Inception version 3. Maybe it's quite takes time in order to train this model. So here's our idea is um, to propose the new methods which able to increase the accuracy and also reduce the complexity of our model. So the first method that we try to combine is the Gabor filter. So basically, the Gabor filter or Gabor function is defined as uh, the product of sinusoid function and the Gaussian distribution function, as you can see from the equation on the slide, right? And basically, we can derive two equations from Gabor filter itself. It's called the imaginary form function and real form function. But in our research today, we only conducted by using the real form only. So there is five different parameter that has to be specified in the Gabor filter in order to use that. The first one is uh, the theta parameter. It's called orientation theta. The parameter theta is also will specify direction of the Gabor filter itself. As you can see from the image in the row one, it's you can see the different um, interval value can be specified there. So we try to take sequence uh, value from 0 to 2p for the theta parameter. And also there is second parameter is called the lambda parameter. In general, the acceptable value of lambda should greater than or equal to 0. So in this our um, visualization, we just took the value parameter from 2 to 16. And also there is another parameters called phase offset or P parameter, and which represents the argument of the sine or cosine factor, as you can see from the equation there. And there's also the aspect ratio, right? Is a gamma parameter. These parameters define the elasticity of the Gabor function itself. So the acceptable value for this parameter is between 0 to 1. So this parameter basically will describe the larger bands of the Gabor filter itself. So the last parameter will be the sigma parameter, uh, where all we know that this sigma is represent deviation in Gaussian distribution. So this value will determine the number of bands, as you can see from the image in the row A. It's the smaller sigma will be create the larger number of bands. So right, and the next method that we combine with it's called Siamese network. So basically, the Siamese network itself, this category of network, its design typically consists of two or more identical subnetwork, right? So the configuration, parameter, weight of each subnetwork are identical. So because the parameter are replicates on all subnetwork. And in this network, basically we are going to apply the um, triplet loss for the loss function. So by definition, uh, must be three input sample images, namely anchor, a positive and negative sample image. So the idea behind the triplet loss is to ensure that the anchor image has the closest distance to the positive image in the embedding subspace actually. And um, distance from anchor to negative image has to be farther than the positive image. So as you can see from the uh, L triplet function, loss function, there's also alpha. Alpha is represents a margin to maintain the large distance between the positive image and negative image. So according to loss function, there is three categories of triplet loss. Okay, so the first one would be uh, easy triplet, where we will have loss equal to zero, and second one will be hard triplet if we assume that alpha is equal to zero. And the last one is this semi-hard triplet. So this is a triplet where the positive is close to the encode and negative image, but it's still hard because the distance is still inside the margin. Right. So in Siamese network, we apply this description of architecture. So basically, a really simple architecture. We have two convolution layer and two calling layer with the drop out regulation in the network itself. So and we also put the fully connected with the size of 256. And so basically, the idea is we apply the Gabor filter uh, to the first convolutional layer in our network. So the only layer that we apply the Gabor filter. So, but it actually is possible to apply to all the layer, but it's not satisfied for the result. So, uh, this the idea is uh, to embed the Gabor filter only in the lower layer. So this is the scenario that we have done is the first we try to use the normal CMS network without Gabor filter, and then second one we applied Gabor filter in the first layer. So there is two network here. Let's assume that those two network is network one and network two. So the experimental setup here is we uh, apply our methods in this data set, which have 70,000 images, where there is 60,000 for training and 10,000 testing. And normally it's has 28 pixel images. So I think it is the most common or well-known benchmark dataset of handwritten digit, right? So we use the MNIST dataset because it's still a challenging one, or we can easily compare with the others algorithm has been found, and also due to its inherent variation in digits, also scale, and also affected by issues such as blurring and variation in intensity. So I think it's making still interesting for the classification study. And because the Siamese network has no classification layer, or yeah, classification layer in the last layer, so we try to apply KNN, Kearns network for baseline classifier. And here's the hyperparameter for Gabor filter that we have created. So we use, let's say, um, theta from 0 to 2p, and lambda, and etc. etc. And here the setup of learning, uh, we use the Adam for estimation algorithm, and learning rate is equal to 0.001, and so on. And then we use the epoch equal to 15. So here's the result. So we try to see the differences between without Gabor filter and with the Gabor filters. So as you can see from these two uh, line there, um, Chavez network with the Gabor filter is basically uh, has the lower loss equal to 0 point something if you compare with the original Siamese network with the loss of 0.25 something. And also we after the embedding process over, and then we employs the KNN classifier. Of course, we um, first we were using elbow method. This is the common use in to find the best key values for KNN algorithm. So we test key value from 1 to 15. As you can see from figure 6, it's it shows that the uh, Siamese network without the Gauss filter has the best key value equal to 3, and then ideal number of the Siamese network for with Gauss filter for key equal to 6.
Mr. Sumara, please keep an eye on the time.
Okay, okay. So this and then the last thing is we try to visualize the accuracy in each class. So uh, we have uh, results shows that our proposed model is slightly better performs the normal network, and also in especially in class 8, the accuracy obtained by network 2 is clearly higher than network 1. So this has 1 point something percent differences between. And also the lastly, we also compare our proposed model with the existing methods where has been found recently. So in the uh, according to accuracy, our network 2 or our proposed model is slightly better or slightly outperform the others algorithms. So finally come to the conclusion. So we have shown that the Gabor filter is effective in the Siamese network with the given parameter, and also we have this conclude that uh, real part or real function of Gabor filter is suitable for this network. And also the fusion of the Siamese network and Gabor filter it could be uh, more improved to the future research. So for that upcoming project, we try to more elaborate and found new configuration for Siamese network based on two function, real form function and imaginary form function from Gabor filter. Thank you very much.
Okay, thank you. We have time for a few questions. Awari? And I have a question. I noticed that you didn't use all the variations of the parameters for the Gabor filters. I think that last one that was alpha, I don't remember it one. You didn't explore all the combinations. Did you try to use more Gabor filters to see if the results get better?
That's very good question actually. So this is very first stage of the research, and we have upcoming project of upcoming research. It's related to the comprehensive the experiment. So like you said, there we try different way to create the parameter in Gabor filter, and then we also try to different configuration of our network also. And another things we try also the differences of the classifier algorithm. So there is more comprehensive comparisons in upcoming project that we have tried down.
Okay, thank you very much. Any further questions? Oh. Thanks again, Mr. Snell.
Yep. Thank you very much.
The last presentation of this session, just a second. That will be from Felicita Marcela Velasquez Fernandes, Ricardo Velez Moro, and Robert Ipanake. I don't think they are here. So we have a no-show, and we are going to finish the session. Thank you very much for your patience. We are going to have a coffee break, I think, in 5 minutes ago. So you have to find a place and get some group. Thank you. Thank you very much. I'm clueless about Jitsi.
Budimo stati, na share screen. Mi posso cazzo na formaggio, it is finished.
Yes.
How?
Excuse me, sir. Can I stay here? Is it possible to stay here even the presentation is finished?
Μόλις τελείωσε το τέτοιο, μόλις τελείωσε το session. Δεν έχει κλείσει κάτι ο άνθρωπος.
Δεν κλείνει τίποτα, δεν κλείνει. Πρέπει να μένει να σου δείξει την δηλαδή.
Ωραία. Δεν πρέπει να έχουμε το break page.
Ναι.
Φαίνεται. Μπορείς λίγο να το σιτάρεις.
Okay. Yes, I have to put the X a break, but I can do it. How can I get it?
We just need the break page, okay?
Yes, but this. Yes. Yes. It's here.
Sorry, Παναγιώτη, τώρα δεν ήξερα ποιον να φωνάξω.
Why does it talk like this? What is this?
No.
Okay.
Τώρα, ας πούμε, φαίνεται η χάρταξη στο YouTube.
It says.
Τώρα πρέπει να φαίνεται κάτι, αλλά θα ονοματίσει άμα δεν...
What?
Yes, it doesn't work. No, SS.
Oh, okay. Okay, so now we have to share this.
Here, yes.
Where is the tab? Here?
Yes, here. Yes. Okay, thank you.
Great.
Yeah.
Επομένως τώρα, ο επόμενος στο άλλο session δεν πρέπει να πάει σε άλλο room, στο link που δίνει το κάθε.
Σωστά.
Άρα εγώ το απόγευμα δεν κάνω κάτι.
Απλώς συνδέεσαι και κάνεις moderation.
Πώς συνδέομαι, αφού είμαι συνδεδεμένη. Αφού είμαι συνδεδεμένη.
Όχι, από το laptop. Από το laptop που συνδέσεις στο room που έχει το πρόγραμμα.
Περίμενε, δεν έχω καταλάβει. Αυτός ο υπολογιστής είναι επί της ουσίας για τον presenter.
Ναι.
Θέλω λίγο να με βοηθήσεις, να το καταλάβω. Ναι. Ωραία. Οπότε εγώ συνδέω λάπτοπ εδώ το δικό μου. Μπαίνω στο room, στο go του Zitzi
που γράφεις το πρόγραμμα. Βάζεις το username και το password.
Ναι, τα έχω.
Και αυτό. Είσαι moderator μέσα στο room και βλέπεις αν υπάρχει κάποιο πρόβλημα, βλέπεις αν κάποιος ακούγεται.
Καλά, δεν γραμμίσαμε. Καλά, δεν γραμμίσαμε.
Γιατί?
Εντάξει, μέχρι εκεί τώρα, αν υπάρχει κάποιο τεχνικό θέμα, δεν μπορώ.
Ναι, αλλά μην αγχώνεσαι, γιατί πήγα και τους είδες από μέσα. Αυτοί κάθονται, έχουν βάλει όλα τα παράθυρα ανοιχτά στις οθόνες. Όταν υπάρχει πρόβλημα στους στέλνεις, το κοιτάνε αμέσως. Στο WhatsApp.
Εντάξει, δεν απλά είναι άσχετη τώρα γι' αυτό. Συγγνώμη που σε φώναξα. Εν μεταξύ, δεν ήξερα ότι η κοπέλα ήταν εδώ γι' αυτό. Οπότε, ωραία. Επομένως πρέπει να φέρω το laptop.
Ναι.
Να το συνδέσω, Τώρα αυτό έχουμε σε
Ναι. Ναι, το έχουμε κάνει σε το βλέπουμε εδώ.
Σε ποιο room θα είσαι εσύ μετά?
Στο C.
Άρα αν σε χρειαστώ θα σε φωνάξω, είμαι εγώ εδώ.
Ωραία. Ναι, δείτε, αυτό είναι το B.
Αυτό είναι το B. Τι θες εσύ? Δεν μπορώ να φύγω. Το laptop. Ναι, γιατί δεν θέλω να την δώσω τις έτσι, δεν είναι έτσι βάζω με τεχνολογία.
Είναι κάποιος
Vamos. É que essa plataforma aqui pela mulher que vai nesses pais lá.
Good morning. You're for the next session, the chair?
My name is Camelo.
You're the chair?
Yes. For MA1.
Camelo Torre. Camelo Torre, okay. Yes. So we all have a coffee break right now. In about 10 minutes, I think we will...
So in this moment, is coffee?
Yes.
Okay, I need 1 liter of coffee.
Yes, so you can...
Okay, thank you. See you in a few minutes.
Okay.
My name is Camelo. Okay.
Well,
What's your name?
Constantinos.
Constantine. Oh.
I have a Latin name.
Yes. I studied classical school, studied classical theory. And Greek literature, I was the best one in my class.
Oh, so... I think that your bus number is
608, the
yes,
one that I used.
Yes. So we are here in Zograf. Here, this is the bus stop. You must.
Τι ψάχνουμε,
Τίποτα, του δίνω οδηγίες για το πώς να έρθει με το λεωφορείο.
608.
Ναι.
Το 608 τον αφήνει...
Ναι, αυτό θέλω να του δείξω ποια στάση πρέπει να κατέβει. Καλά, μην...
Εδώ δεν έχεις
Eight.
assistant.
The 8. So you... 8th of Zograf.
Yeah, that's the name of the bus stop.
Because
But...
I went to the last stop.
No, you must leave the bus at 8.
Yeah, it's the 9th or 10th, I think.
11th.
Yeah, it's a cemetery. No, there's another campus.
Okay.
So you have to stop at the 8th of Zograf.
8th of Zograf. And then you will go...
You have to walk to come here.
About
okay?
10 minutes, you will go the opposite direction of the bus, about 10, 20, 30 minutes, and then you go uphill.
Nice.
And when you stop going uphill, you will see the entrance of the NTUA.
So this faculty.
So you go here, you walk a little bit the opposite direction, and then you go this direction, which is uphill, like this.
Να το εξηγήσουμε
And
ότι η είσοδος, this is the entrance of the campus. Okay, so you have to walk from here to here to get, because it doesn't, the bus doesn't stop outside the campus. So you have to walk, and you have to go to cross maybe the whole campus to come here.
Yeah, I did that,
Okay.
but
I know it's a bit complicated.
And when you leave the campus, it's much easier because the bus stop is outside the entrance.
To leave, not to arrive.
To leave it's very easy. To arrive it's a bit complicated.
Or what? It's the same 608 or other bus?
The
No,
same
608.
Where from which station do you get the bus?
Something with A.
Something with?
A.
Annexe. This Annexe.
Yes.
Huh?
Yes, I guess.
So you can also take the bus 230.
Yes.
608 or 230. They're the same. The two. These two
Από
buses.
230 λες, Ακρόπολη, κάτι, yes.
But you must walk from Annexe. When you come to the campus, you must walk to this station, the next Kotopouli. There are two buses going to the 8th of Zograf.
Okay.
if you go to the next station, you have two. You can choose between two buses. But on this direction, both buses stop at this station. And I think it's the opposite direction. It is. The station must leave is Kotopouli. Yeah, there is no annex station in this direction.
Okay.
You must, because then you will go here, it is a little bit more far away from your destination, I think.
Okay. Thank you very much. That will save.
I hope we helped.
Yes, a lot.
I know things are a bit complicated.
It took him 20 minutes to work.
It took me 15 minutes to find the building, and I'm Greek. And I'm supposed to study here, but okay.
Κάτσε, θες να κάνεις κάτι?
Όχι. Θέλω να ρωτήσω κάτι. Δεν έχουμε chair εδώ.
Είχαμε.
Είχαμε technical assistant.
Όχι, είχαμε και chair.
Είχαμε και chair. Okay.
Αλλά το έκανε μέσω email, δεν είχε...
Το έκανε online, ήταν virtual.
Όχι, ήρθε εδώ. Εδώ ήταν.
Γιατί πριν...
Θες να στο δείξω?
Όχι, απλά θέλω να ξέρω ότι έχουμε chair εδώ.
Εδώ είχαμε, τελείωσε αυτό το session.
Ωραία.
Τώρα πάμε σε αυτό που πάλι μου ήρθε το chair.
Σου ήρθε.
Ναι. Ο Καραμέλο τώρα ήρθε.
Ναι. Και έχουμε τον ίδιο technical assistant. Θέλω απλά να μείνω εδώ να δω τι θα κάνει ο technical assistant, γιατί μετά το μεσημέρι θα είμαι εγώ και δεν ξέρω τι θα κάνω.
Τίποτα, απλά μπαίνεις με ένα κωδικό στο virtual room.
Τα έχω αυτά.
Μόνο αυτό κάνει.
Εντάξει, θα είμαι εδώ. Μπορείς να πας λίγο στο Gigi, πώς λέγεται αυτό, να δούμε τι ώρα έχουμε βάλει εμείς. Είμαστε τώρα, γιατί μήπως ξέρω, εδώ δεν είμαστε. 3:30 φαίνεται. 3:30 PM. Δεν είναι 3:30, παιδιά. Υπάρχει κάποιο refresh εδώ. Performance settings. Είπε να κάνουμε refresh για την ώρα, αλλά...
Τι χαρά δεν είναι η ώρα αυτή, 11 παρά 5 δεν είναι. Καλά τα λέει.
Όχι, το will continue at που λέει θα ξεκινήσει στις 3:30. Δεν θα ξεκινήσει στις 3:30, θα ξεκινήσει το επόμενο session. Τώρα είναι τόσο.
Εντάξει, μήπως εννοεί μετά το διακοπή θα ξεκινήσει πάλι μετά τότε. Η διακοπή γιατί είναι τόσο μεγάλη, προβλέπετε κάτι, μόνο για το φαγητό του τώρα έχουμε. Βλέπω ότι είναι από τις 1 σχεδόν μέχρι τις 3:30 διακοπή.
Θα φάνε τώρα, Τώρα τι ώρα ξεκινάμε?
Άρα εδώ θα τα κλειδώσουμε λογικά μετά και θα πάμε ο καθένας στο...
Ξεκινάμε στις 11, υποτίθεται. Ωραία. 11 με 12 και 20. Τώρα τελειώνουν οι άλλοι. Τώρα τελειώνουν οι άλλοι, το πρώτο σύστημα. Εντάξει, έγινε σήμερα. Και μετά είναι, όντως, 3:30 είναι μετά. Ωραία. Εδώ έχουμε τον Ρακέλ, αλλά θα είμαι εγώ, από ό,τι ξέρω. Τις παρουσιάσεις τους δεν πρέπει να τις φέρνουμε εδώ να τις φορτώσουμε.
Ναι. Αυτή που ήταν technical assistance είχε παρουσίαση το πρωί.
Τι?
Αυτή που ήταν technical assistance είχε παρουσίαση το πρωί. Έχεις λέω μπες στο chat στο virtual room και μετά φύγε. Δεν ξέρω να κάνω την έντυπωση.
Ωραία, πότε μας θα χρειαστώ.
Ναι, εγώ θα είμαι εδώ.
Τώρα κοιμούνται στις 6.30, οπότε είναι μια χαρά.
Απλά θα έπρεπε να έρθουν λίγο να φορτώσουν τις παρουσιάσεις τους. Παρουσιάζεις εσύ, Κώστα? Εδώ παρουσιάζεις. Θες να παρουσιάσεις τα βρήκα μένα. Έκανα την παρουσίαση και ενώ την έφτιαξα και δεν ξέρω τι να σου πω.
Δεν πρόλαβα να είστε, είχα ετοιμάσει ένα paper, αλλά
Τον Καλά.
πότε είναι το καλά.
Τον Καλά έκανε μια μάζοψη της ημέρας της Άνσης Έκας
Τα αγγλικά το έχεις, να είσαι στην web.
Ξέρω να γράφω αυτή τα καλά. Δεν γράφω. Θέλω να σκεφτώ. Μ' αρέσει αυτή η λέξη. Να ψάξω ένα λεξικό. Να πω ένα συγγνώμη. Όταν μιλάς, δεν είναι να πω καλά. Δεν το έχεις πω.
Αν είσαι πολύ μπράβο στην ελληνική.
Με βόλεψε. Γιατί ήταν το θέμα τέτοιο, με όλη την ορολογία, να μην μπορώ να την μεταφράσω στα ελληνικά, ειδικά τα τεχνολογικά, και εντάξει, τέλος στα αγγλικά τα διαβάζω όλα και να στα γράψω. Με βοήθησε.
Είναι καλό, γιατί δεν ξέρεις καμιά έντονη αναφορά, γιατί σου πει τα ελληνικά, είχε έτσι.
Εντάξει, καλά, καλό το διδακτορικό που σε κάτσε να το πάρεις από έξω. Τα papers είναι το θέμα.
Δεν ζήσεις άλλο που κουράζει.
Αλλά το εντάξει, το δικό μου δεν είναι και κανένα. Δεν θα βγάλω το μυαλό για να το κάνει site, αλλά λίγο. Πάω να δω τι γίνεται έξω. Now, and then I'll be here.
Have another presentation?
Yes.
Now?
She is.
Okay.
Sadly,
So, you are again, we have connected to which room, so make yourself comfortable and be anxious about where you did not have any problem with it.
What do you do?
My research. My research is sustainability. It's not very related to this.
So it's
And here, it's a system. Helping pieces to make and if some say I don't attend the classroom, then I take this position at something else.
yes. It would be very helpful in class like that moment. That someone care about you.
So your evaluations
So trying to find a way to measure.
Our common topic is cycling.
Really? Where?
I have one to papers cycling.
Yes. You have to send me. I'm really curious about. Because it's very difficult to do this sector as versus output, so touch and then
Yes.
so every subject or every topic given some aspect and so I'm curious about. So I'm going to go back.
Okay. Have a nice presentation.
Thank you.
Do you have a presentation? No.
Yes, I have a presentation. Do you have? Yes.
You're not the chairman?
No, I'm not the chair.
Oh, okay.
This seems to be an Italian session.
Yes, I know.
Where is everybody?
Is the chair?
No.
No, I'm not. The chair is having coffee at the coffee break.
Okay. So just to be sure that that's a shared as every session.
Yes.
Which one?
You have to scroll down till the end, and there should be a PowerPoint or the PDF, maybe better.
I will copy both, so you choose whatever you want. So, which beautiful Italian city do you come from?
I come from Venice.
Venice. Oh, the most beautiful city.
Yes.
The most romantic city.
Maybe. Maybe. Can I take it?
One moment. And you came here through the airport from Venice to Athens?
No, from Bologna, because
Bologna.
Yes,
Oh.
because the flight from Venice is in the evening, so I departed early this morning.
So very time consuming.
Yes.
The train and
Yes, really.
When you Italians are close to us, the Brazilians are the most 14 hours flight.
Doesn't the session start at 11?
Our chair is missing.
Επίσης, λήφθηκε ο technical assistant.
Technical assistant told me that she is not going to attend because she has a presentation in another room.
Πρέπει να φέρω υπολογιστή. Πώς θα το κάνουμε? Αυτό είναι το δεύτερο υπολογιστή. Να το κάνουμε.
Γιατί?
Αυτό μου είπαμε. Πρέπει να φέρουμε υπολογιστή, να το συνδέσουμε για να συνδεθούμε στο room το...
Όχι, είμαστε συνδεδεμένοι στο room.
Τι μου έλεγε ο Παναγιώτης?
Είμαστε συνδεδεμένοι κανονικά.
Οκ. Δεν καταλαβαίνω. Μου είπαν ότι ο technical assistant πρέπει να έχει ο moderator, όχι ο technical assistant, το δικό του laptop να συνδεθεί για να κάνει join το room. Δεν έχω καταλάβει. Πραγματικά μου λένε ότι είναι άλλο.
Εμείς θα κάνουμε όλα σε ένα.
Γιατί ρώτησα, αυτό το room είναι ανοιχτό. Okay.
Our chair.
Hi. Hello.
So shall we begin with or not?
Yes, I think yes. But there are many people in the breakfast area.
Για βγάλε μου λίγο το...
Γιατί τώρα εγώ εδώ είμαι... Είναι το sharing.
You know the poetry?
Άνοιξε την κάμερα.
Δεν ξέρω τώρα πώς θα γίνει.
Okay, you know the poetry? Drink wine, young men. There is a warm temperature, and women are tired. Women are tired. Is very fragment direction. I studied literature.
Yes.
Συγγνώμη, ο κύριος που ήταν πριν εδώ, από τη Βραζιλία, ήταν ο Τσεάρ. Και ποιος ήταν ο technical assistant, ποιος ήταν αυτός?
Εγώ θα είμαι τώρα, αφού λείπουν όλοι.
Δεν είναι έτσι, γιατί έχω άλλα στοιχεία.
Θα έρθει, μου είπε, έχει μια παρουσίαση και θα έρθει.
Ναι,
Yes, I think Italy too or not.
Yes.
Which city do you come from?
I live in Bari. That's
Oh, so you're very close to
But
us.
from Sicilia. I'm Sicilian. Sicilian.
So you have warmer temperatures than we have.
Yes, there is a period, but they are speaking about global warming and something
You.
Yes, I need the paper. Okay, thank you. I have some difficulty to connect the net because it's asking my. Yes, thank you. Okay.
NTUX is the NTUAX.
Okay. Okay.
NTUAX is the one NTUAX. So the next is this. The next. Okay.
Okay. Grazie. If you agree, good morning, first of all. And this is the second session and in MB for everywhere. And just I ask to you to wait some minutes, just to maybe if there is somebody coming in the classroom, some few minutes, and after we can start. Do you agree with me? Okay.
I'd like to let you know that colleague will present online.
Yeah.
It's Dr. Santamato, and it's scheduled for the 20.
Okay. If we manage the list, we have at the beginning Francesca Nocca, paper by Francesca Nocca, Giuliano Poli, Alessandra Staiano, and Maria Cerreta. Second one is the author are Sofia Cafiero and Maria Cerreta. After Simona Panaro and Maria Cerreta, at the end Dario Esposito and Vito Santamato. So these are the colleagues that are introducing their paper. And I think that only for Vito Santamato and Dario Esposito will be online, because in the program was written in presence.
Okay.
Okay.
I think she is connected, so I think that we should just give him the floor.
Mm-hmm. And can you tell me the name of your colleague, because here it's not.
Vito Santamato.
Okay, is it?
He will present.
Okay.
Yes.
Okay. Thank
It's
you.
already online. Yeah.
Thank you. Okay, we respect the order and as is in our paper. Okay. So the first paper to be introduced. The author are Alessandra Staiano, Francesca Nocca, Giuliano Poli, and Maria Cerreta. Who is going to introduce?
Yes, good morning. We are here online. There is also Alessandra Staiano that will present our contribution by me, I am Francesca Nocca, good morning everyone, and by Giuliano Poli and Maria Cerreta. Alessandra, I think you can share your screen.
Okay. So, are you the speaker?
Alessandra Staiano is the speaker, yes.
Okay, thank you.
Okay. Good morning. I'm Alessandra Staiano, and with Francesca Nocca, Giuliano Poli, and Maria Cerreta present the work Short-Term Island Sharing Economy, Real Estate Market and Touristification Interplay in Capri, Italy. This study, developed with the PRIN Research project Short-Term City Digital Platform and Spatial Injustice, aim to analyze the impact of short-term rental and related touch and go tourism on cities. After examining the general impact of the development of Airbnb, it aims to answer some questions, focusing on the analysis of this phenomenon on the island of Capri in Italy. The work is structured as follows. First, main research questions are posed. Then, the general and theoretical framework of the phenomenon is described. Section 3 presents the case study, the island of Capri, focusing on the tourist vocation of the place. Section 4 describes the methodological approach of the research. Section 5 presents the result, and finally, summary conclusions are drawn. In recent years, we have seen global tourism continue to grow exponentially. However, it happens that tourism, if not well managed and therefore in absence of clear long-term vision, can have a negative effect on the urban system. So the research objectives are to understand the impact of the proliferation of Airbnb is having on the traditional market of buying and renting. To know how does the proliferation of Airbnb on Capri Island affect the quality of life of its inhabitants and their right to housing and work, to develop a sustainable tourism model for Capri Island that preserves history, the environment, the community, and the economy. The sharing economy has grown exponentially since 2008, following the great financial and then economic crisis, and has been supported by a wave of major technological innovations. In 2012, Bosman and Roger used the expression collaborative consumption to describe the emerging sharing economy. From a macroeconomic point of view, the assumption falls within the definition of the hybrid models of the circular economy, in which nothing is wasted and everything is reintroduced into the loops, becoming a resource. The social intention behind the phenomenon was cancelled out by the appearance of a profitable element. The efficiency generated by platform extends to the entire economy. In home sharing sector since 2008, Airbnb has offered an online platform that connects hosts of houses and rooms for rent with guests looking to rent in order to facilitate the search for availability of houses and rooms and to act as intermediary for payments. The site is financed by a commission on each rental, which varies between 6 and 12% of what the guest pays and 3% of what the host receives. Airbnb strategy is based on creating a gap to increase the real value of rentals. This creates a demand for gentrification and touristification in historic centers and has negative effects on the cities where it's operated. Wealth is concentrated in the hands of a few absent landlords who rent out to tertiary tourists, driving up property values and rents, concentrating the supply of rental accommodation, and thus driving middle and lower classes away from the urban centers. Capri Island is located in Tyrrhenian Sea. Administratively, the island is divided into municipalities, Capri and Anacapri. Known as a grand tour destination in the 19th century, the island started to develop an art of reception. This resulted in the progressive decline of the agriculture and coral production in favor of tourism, still today the most important driving force of the island. Three many types of tourists can be distinguished. The touch and go type concentrate in the area of Marina Grande, the port area of the island. A type of worldly tourism that is more focused on the town of Capri, the more famous side of the island, known for its luxury shops, nightclubs, and famous piazzetta. And finally, there is a slow tourism. This is a unique type of tourism that focuses on an in-depth experience that allows you to immerse yourself in the ecosystem of the place. This type of tourism is particularly attractive for the town of Anacapri, which is the opposite of Capri, simple with a more private and discreet ambience. If Anacapri has always been less tourist than Capri, it has also been hit by the massive influx of tourists in recent years, which is why the study reports distortion in the property market. The methodological workflow was structured in following phases: research and data collection from the Airbnb platform, analysis and extraction of data from website and DNA in order to investigate the dynamics of the short rent real estate market in Capri and Anacapri, analysis of the dynamics of a traditional real estate market on the island of Capri, a comparison with the Airbnb market, proposal for a more sustainable in Capri. So, first we took the number of advertisement on the island of Capri and placed them on a map. Capri is more active in terms of tourism than Anacapri, as shown by the different number of advertisement between the two municipalities. In particular, in Capri, 87% of listings are concerned houses and flats. So, contrary to Airbnb's claims, this significant percentage suggests that there are not sharing spaces, but flats that generate extra income in houses where no one lives. Moreover, only 30% of listings are run by hosts that we consider privated. The rhetoric of sharing promoted by Airbnb is at odds with the evidence of an extremely unequal distribution of income. The contradiction between the platform's slogan and the way it is actually used seems obvious. What Airbnb promotes are unused rooms offered by locals offering hospitality and affordable price has become a real business. Being placed known for its scenic living characteristics, especially in summer, it is not surprising that most visitors arrive between June and August. It is therefore been observed that in terms of rental growth, owners tend to make their properties available mainly in the third quarter of the year, the summer quarter, with a sharp drop in the winter quarter. The same sinusoidal trend is seen in demand growth. Although 2019 was an exceptional year for the island tourism industry, with a record number of visitors, this figure was matching in 2021 and exceeding 2022. Only in 2020 was there a slowdown in demand growth, apparently due to the COVID-19 pandemic. An analysis of rental revenues over the years in the two municipalities was then reported. The income generated by Airbnb is clearly significant. In both Capri and Anacapri, the highest revenues were generated in July 2022, with some differences. The revenues generated by Airbnb in the municipality of Capri are much more stable, sometimes even double or triple those in Anacapri, which, as already mentioned, was hit by massive tourism later than Capri. In any case, there are extremely important revenues. In third phase, the concentration of the advertisement in different home zones of the island was studied. From this, it was first of all possible to understand that the majority of listings fall in the historic centers of the two municipalities. This data was then correlated with the number of buildings intended for residential use, from which it was possible to quantify the percentage of buildings removed from the ordinary residential market. The subtraction of much of the housing has as one of the first consequences that house prices have risen beyond the reach of most residents, who are faced with a market that is much higher than the official quotation published by the Borsino Immobiliare, where once again the peaks were reached in July 2022. The tourism sector contributes to creation of value and jobs, but if it is not well managed, it risks become damaging the local communities and places themselves. If it's true that the tourism sector generates employment, we must constantly question the nature of this work, which in Italy and especially in Capri Island is seasonal, occasional, with temporary contracts, and on the impact that tourism has on the lives of the inhabitants of the place visited. Over-tourism is not only a consequence of private interest at stake, but also of a strategy of urban growth by public administration that promotes tourism growth will also complaining about its effects. This contradiction is the result of an unsustainable growth model. Sustainable tourism is a broad term to describe responsible travel practice that respects the environment, a culture, or a population. In this perspective, a new platform called Inside Capi is here proposed, aimed at the valorization of local cultural heritage and cooperation among tourists and the community. The platform was developed to propose an alternative program for communication and reporting about Capri Island. The platform is based on a logic of sharing and collaboration in line with the circular economy principles. As you scroll the page, a first section aims to propose experiences that are related not only to learning about the area, but also learning about the local cultural history. It provides information for local cooking classes, excursions, unconventional tours, and immersive experience with local guides. Furthermore, through Inside Capri, an unconventional map can be consulted to promote a wider knowledge of the area, showing the most intrinsic and significant place of the island. In fact, some of territory's most important places are shown. By framing the QR code, you can access websites with detailed description of these, which are usually invisible to visitors. The map can be downloaded from the platform at any time. Finally, there is a section dedicated to cover most important municipality and traditional events. So, in conclusion, we can say that Airbnb's activity tend to deviate from the sharing economy model it claims to follow. That Airbnb listings tend to be concentrated in historic centers, gentrified neighborhoods, and adjacent areas, and not at the platform claims in suburban areas that are typically excluded from tourist traffic. Even on island of Capri, the short-term rental market ends up crowding out the long-term housing market. This significantly reduces the house stock and thus increases house rental price. In the scarcity of forward-thinking government policies, or in a context such as the current one where tourism is extremely encouraged, strategies for more sustainable tourism are needed. Platform for exchange of knowledge, such as the proposed Inside Capi, aim to develop a progressive and shared construction of the history of the territory, helping to understand its characteristics and enabling the inhabitants to share their history and life experiences in order to make tourists see the territorial resource in a different light. Thank you for the attention.
Thank you. Is anybody want to? There is somebody who want to put some question to the about the paper? No. Okay. So we pass to the. Thank you, and we pass to the next one, and the author are Edda Donati and Sergio Copiello. And this is Presses. Can I support you? Okay. Yes.
Okay. Thank you.
Hai tutta la mia solidarietà.
Aspetta.
Come?
Sì, sì, solo che bisogna
attivare il monitor. Okay. Do you want the PDF?
Yes,
or
the PDF.
PDF. PowerPoint to PDF.
PDF.
Yes. Okay. Ok, se piace di guardarti in faccia. Copiello?
Yes.
Now I think you can.
Can I go? Okay, thank you. So good morning. My name is Sergio Copiello. I'm an associate professor at the University you have in Venice, Italy, and I'm going to present you a study on the so-called one-stop shop business model, which can be adapted, among others, in order to improve building energy efficiency. But before, let me make a step back and brief digression here to explain the framework of this study and the underlying assumption. We all know that energy efficiency occupies a prominent place on the agenda, starting at least from the 70s. The oil shocks of that time put tremendous pressure on many countries and the economic system in order to improve how energy is used. In the beginning, attention was paid most of all to the achievement of energy saving targets. Later, the focus shifted to the improvement of energy performance and energy efficiency, not to mention the achievement of environmental objectives, so CO2 emission reduction, for instance, as well as mitigation of global warming and climate change processes. The building industry has been the target of several regulations in an attempt to strengthen how much buildings use energy. In particular, concerning the construction industry and the real estate market of the European Union countries, in the last 2 decades, the EPBD set the legal framework for the national incentive policies and measures, which include mandatory standards, subsidies, tax rebates, as well as other kind of in cash and in-kind incentives. Well, the underlying assumption of this study is that the EU-wide legal framework and the wide range of incentive policies and measures put in place so far by EU member countries have in turn stimulated the rise and development of innovative and most of all tailored business models. So entrepreneurial approaches that are explicitly meant to exploit the business opportunities offered by those incentives and their effects in terms of revenue generation and profit growth, especially by the so-called price instruments or economic incentive tools, both direct, such as grants and subsidies, and indirect as tax rebates. This is not only the assumption of this presentation of the studies of the study we are presenting. It is the background hypothesis of doctoral research I'm currently supervising. So this presentation is actually part of a broader study to be completed in about a year and a half. Since this is part of a broader research activity, in my presentation, I'm going to focus on a specific entrepreneurial model only, which is the so-called one-stop shop. One-stop shop is a common locution in several fields. It is used to denote the integrated offer of products, services, or solutions by a private entity to its customers or by a public body to its users. It is also used to identify a business model that is making its way into the building industry too, especially for carrying out refurbishment work. The primary feature thus is the presence of an individual contractor who is essentially responsible for everything. It's responsible for the project's quality. The contractor also bears the upfront cost and undertakes the task of performing all the required improvement work in order to satisfy the customer or the customers. So during the doctoral research I mentioned before, a search has been performed for innovative business model in the building industry, especially meant to carry out efficiency-related work. This search has led to the identification of about 50 case studies across Germany, France, Spain, Belgium, and the Netherlands, so Central European countries. And of those 50 case studies, 14 cases fall within the framework and the strict definition of the one-stop shop business model. So this study aims to provide an overview of their distinctive feature. In particular, we are interested in recognizing and determining both the commonalities among the case studies and the differentiation factors. Incidentally, the ultimate goal of the broad PhD research is to identify the best practices. Those business models that are suitable for further development, and most of all that can be, so to speak, successfully shifted and exported to other EU member countries. So this step is a sort of step in that direction. Concerning the method, we adopted the rough set analysis. That's because we deal with both quantitative and qualitative data. Also because the variables we consider are an incomplete characterization and representation of the case studies, and most of all, they sometimes include presses, vogue, or even noisy information too. We performed the analysis using the software ROSE tool, which was developed by the Intelligent Decision Support System Laboratory at the Poznan University of Technologies. This software features a package of rule inductions based on the rough set theory. Essentially, it is a classification technique which requires distinguishing between condition attributes and decision attributes. The latter ones are also called evaluation attributes. A kind of analogy can be established with statistical analysis, in particular regression analysis, with each condition attribute playing the role of an independent variable, and at the same time each evaluation attribute represents a dependent variable. Anyhow, the distinction between condition and evaluation attribute doesn't always imply a causal nexus. This is not the case for us. We are simply interested in identifying the relationship between the features of the case studies, that the relationships that suggest that they belong to the same cluster or subset. Quickly, you can see here the names and location of the 14 case studies, mostly in France and Belgium. And here you are the list of the variables, so namely the condition and decision attributes we consider. As you can see, they are clustered into three domains. There are the one referring to the business model, those pertaining to the physical and the energy features of the real estate asset, the refurbishment, and the last set is made of dichotomous variable concerning the efficiency-related works. We use just the first one as a decision attribute, and this enables us to distinguish three primary sets of the analyzed case studies. So, turning to the result to the three main sets, here is the first clearly defined group, clearly defined set. It includes 5 properties owned by public bodies or semi-public organizations. They essentially are local public housing authorities or social housing agency. Most of them are condos. You can see here the first category for the building typology variable, BT, and the renovation works are promoted and directly carried out essentially by construction firm. You see the second category for the financial promoter variable, FP, and the renovation works involve mostly adding insulation layer to the building envelope and replacing the heating system, but not the cooling system. It is, in our opinion, it is pretty interesting to see that the first cluster of case studies includes several subsets, the representation of which is the essence of part of the essence of rough set analysis. So what can we see from these partly overlapping subsets? Aside from some indication about construction materials and building size, it is worth mentioning that renovation work always involve outdated real estate assets built between the 50s and the 70s. After the refurbishment, those buildings can reach the energy rating band B most of the time, sometimes also even the A rating band. The second cluster is much less important in terms of the number of case studies it includes. There are only 3 old middle-sized properties owned by private non-profit companies. 2 out of the 3 case studies share substantial upfront cost in the range of 4 to 8 million euros, but we have to say there is not a significant difference among all the case studies as far as the unit cost, unit refurbishment cost is concerned. Finally, the third cluster, to which 6 properties owned by private for-profit companies belong. Here we can find some interesting exceptions from the, let's say, mainstream features of the analyzer case studies. For instance, we have here 2 case studies that are non-residential buildings, so commercial building in this case. As you can see, the third category for the building typology variable. It is also worth mentioning the occurrence of 2 other case studies where an energy service company plays the role of the individual contractor. And quite interestingly, the 2 cases relying on an ESCO also share the access to incentive measure. You can see the first category for IM incentive, the variable incentive measure here. In particular, those incentives are grants varying between 25 and 50% of the investment cost, made available by ANAH, which is the French National Agency for Housing Improvement that subsidize home comfort enhancement. On the contrary, when a construction firm plays the role of the individual contractor, the use of incentive measure is much less common. In conclusion, we found that different kinds of property owners rely on the one-stop shop business model. The contractor is often a construction company, seldom an architectural firm, with a minor role also played by entities such as the energy service companies. Incidentally, the energy service companies are instead predominant in other innovative, tailored business model based on APC, energy performance contracting, or ESC, energy service contracting. They are not the focus of these studies. As I mentioned earlier, we are focusing only on 14 of the 50 case studies we are analyzing around Central Europe. As per the energy refurbishment of the properties, we also found that there may be some quite interesting limitations due to the combination of constraints concerning building age on the one end and the kind of efficiency related works on the other end. In fact, we have that several case studies involve mid-tier buildings. They are not so bad as far as the energy performance is concerned. So they are rated from D to E before the refurbishment. Later, the rating becomes B or only C or even only D once the refurbishment is done. So there is an improvement, but it is not so wide. In our hypothesis is that, and we are going to delve into this hypothesis, is that that depends on some kind of constraint between building age, the availability of grants and subsidies, and the kind of efficiency related work that are to be carried out. I'm done. Thank you for your attention.
Thank you.
Is there anybody that some question? Okay, I'm just curious about the sample that you adopted, because I think that it's very complicated in context of this study. How can you get your information?
The sources for the case study.
Have you been supported, for instance, from some public institution?
No. We essentially relied on two main sources. On the one hand, reports drafted and published in the framework of EU-funded projects, research projects, and so all the deliverable from several of these projects have been useful for us in order to identify the list of the case studies and also to get some a bit of information about the case studies. The data has been complemented by the data we searched and found in another primary source, which is constituted by public monitor, publicly accessible monitor on especially several phenomena affecting the building industry. And also we searched in other presentation, but that is only to find specific data about the case study. We also contacted. Yes.
How to say? I'm very pessimistic about the tons of papers related with COVID period and real estate market.
No.
I read everything and the opposite of everything.
And there are a lot.
So it's very difficult to focus some questions or problem related with the place. Because, okay, we have market, but if you just speak about like a statistical survey, but without connecting with the environment and so some of the main characters that can affect the market.
Yes, I agree, and that's the reason why we try to reach out all the responsible
If you take
of the case study.
abroad, you can have
Yes.
comparison, is it?
Yes, but we get answers only by two of them. So at the beginning, we were thinking about go deeper on each of the case studies. Now we are thinking about make an in-depth analysis. I mean, looking at the balance sheets, at every kind of document you can have from the building sites and so forth, only for a French case study and a Belgian one, because it's the only two for which we were able to get detailed information. I mean, bill of quantities, financial, detailed financial reports and so forth.
Okay, I'm happy to your discussion. Thanks, and just make a joke. Finally, we are not speaking about COVID from every point of view. Okay.
Thank you very much.
Are there some questions? Other questions? Okay. We can exchange our chair.
Yes.
Attention to cable.
Yes, it's very hard to get out.
Yes.
Thank you.
You're welcome. Okay. Occhiali. Copiello. Now is where is my okay. Quindi Sofia I'm getting old. Sofia Cafaro and Maria Scerreta, they introduce the new paper is very small. Yes. Creative culture strategies for sustainable innovation, the multidimensional valorization project of the Pioppi Living Museum of the Sea. Who's introducing? Are you introducing? Oh, okay. I was joking again. Who is online?
Yeah.
No.
Good morning, everyone. Can you hear me?
Yes.
Okay. I share the mic.
How? Thanks.
Can you see the presentation?
Yes.
Okay.
Just some minutes. Okay.
Okay. So the contribution I will present is about creative culture-led strategies for sustainable innovation. In particular, the multidimensional valorization project of the Pioppi Living Museum of the Sea in the south of Italy. These are the steps that we will follow in the presentation. Start with an introduction of the phenomenon,
Then I'll talk about the materials and methods that have been used. Then I will present the case study of the Museum of Pioppi, and then the results will be explicited. We can start from the consideration that the cultural and creative supply chain is fundamental in developing national, human, and territorial capital, not only in Italy or in Europe, but also in the global dimension, as we can see from the UNESCO data report. And in this perspective, the policies for the valorization of cultural heritage, particular attention is paid to the role and the contribution of museums for their potential to mobilize economic resources and to be drivers in urban and territorial regeneration processes. And this is particularly valid for eco-museums, including aquariums, that are historically based on their attractiveness and scientific relevance, but also require strategies and steps accompanied by adequate creativity and the ability to build and maintain territorial links with their context. And the contribution develops reflection on the role of aquariums, outlining a methodological approach aimed at identifying a valorization strategy for the aquarium of Pioppi in the national park of Chieti. The research started from the analysis of the spread and the decline of the aquariology and from a comparison of the various European experiences. And observing the collected data, we can see how the loss of attractiveness and of scientific functionality led to the conversion of aquaria into more profitable activities or to closure to bankruptcy. So we only have three historical aquaria still active today. And the research focused on the case of the aquarium of Naples, known as Zoological Station of Naples, that was activated with the intention of enhancing scientific research and was developed thanks to the creative and enterprise skills of its founder and director, the biologist Anton Dorn. And the combination of the successful strategy with some peculiarities in station management model led to have a balance sheet always in surplus. And this suggests how the innovation strategy can be reused and reinterpreted in the cases under study nowadays. The multidimensional valorization project of the Museum of Pioppi has been collaborated using a decision software system articulated in four main phases. The first one was the knowledge of the cultural context and the identification of the stakeholders. And in particular, the methodological process was carried out on the survey and the representation of the building out in the aquarium. It was necessary to put forward a multidimensional valorization proposal, also aimed at developing a reorganization of the exhibition spaces. In the second step, the elaboration step, the different types of information collected in the first phase were complemented using a checklist formulated by ICOM and OECD to identify possible local administrative policies and also instruments available to museums and to public administration, and verifying their implementation under the specific conditions of the case study analyzed. Finally, in the evaluation phase, the constructed scenarios were subjected to structured multi-criteria analysis with the support of the software 2.0 to establish an order of preference and select the alternative to elaborate the enhancement strategy
that is explicated in the last step, together with the programming of activities. The Eco Museum under study, the Musea, is in POP, a village in the touristic and naturalistic context of the Cilento National Park. Is housed in the historic Palazzo Vinciprova. This case is paradigmatic in terms of both criticality and potential. It is one of the Italian aquariums owned by a public body and managed by a non-profit organization. Moreover, its insertion in the context of a small village underlines its territorial vocation and its capacity to generate positive impacts on the local community. And its different vocations and the variety of local resources give the possibility of developing scenarios able to enhance different roles of the musea. From the different analyses made with a survey of socioeconomic data, it was possible to structure a mapping of the stakeholders involved and potential involved in the museum activities, and this allows to understand the socioeconomic environment of the museum and to identify the resources and the possibilities for its development. Furthermore, within the group represented by the visitors, a number of relevant categories are distinguished using parameters such as the period of the visit, the demand for activities, and the services that can be offered by the museum. According to the guidelines of the International Council of Museums, the ICOM, and the OECD, strategies have been defined to maximize cultural impact through policies and instruments available to both museum, institutions, and public administrations. For each of the teams, action and possible policies were identified and analyzed through a checklist indicating which are to be introduced, which are to be increased, and which are to be enhanced. The knowledge of these processes has made it possible to structure the planning of musea's activities, and so the program of activities, administrative policies, implementation tools, and the stakeholders involved have taken on different modulations and articulations according to 3 alternative strategic options, each of which refers to a particular vocation that the Eco Museum potentially has, the tourist, the scientific, and the territorial character. To identify the preferred strategic alternative, it was essential to proceed with a multi-criteria evaluation, defining the goals to be maximized and the respective relevant criteria made explicit by indicators defined by the value as it stands and by the expected value for each of the strategic scenarios. Then followed the standardization of all the components of the evaluation metrics, and then the weighting to all criteria to reflect their relative importance in the evaluation process. And in this case, the weighting was based on the classification returned by the checklist of ICOM's selected teams, delineating 3 groups of weights consisting of the criteria linked to the valorization goals and placed in descending order of importance. To examine the alternative options ranking, it has been applied the 4 multi-criteria analysis methods of the software Definite 2.0, and this made it possible to reason in an integrated manner and verify the robustness of the preferred scenario. The preferred strategic alternative was found to correspond to the Musea local community scenario that favors the territorial vocation of the POP aquarium. And this result is also appreciable from the sensitivity analysis carried out by changing the weight attributed to each criterion and comparing the obtained results through other multi-criteria methods. The evaluation of the preferred scenario and the application of the ICOM guidelines allow to construct the program of activities POP Museale that follows the principles of a creative strategy and brings 8 new activities in the museum and 6 new professional profiles that should work as a bridge between the museum and the sea and the territory. And has been also formulated the proposal of the network of Mediterranean aquariums that are identified among the contemporary Italian aquariums according to selection criteria that consider both their specific vocations and both quantitative parameters, which are comparable and compatible with those of the musea. This contribution highlight the role of the multiple components determining the correct and stable functioning of eco-museums and museums institutions. And the aim of the research was to trigger a process of maximizing the cultural and economic impact produced by a public aquarium for the local community, following a decision-making process and applying the ICOM and OECD guidelines. And this methodological process represents a starting point that can be repeated and developed with the stakeholders' active participation. Thank you for your attention. I cannot hear you.
Okay, now you hear me, is it? Is it? Are you there? No. Is working, theory. Sparita pure l'immagine.
Non mi vedete?
Sì, non sullo schermo principale. Comunque sente, dottoressa? Sì. Quindi una domanda la possiamo fare? Sulla scelta dei metodi di votazione. Ah, sì, scusate. I'm sorry. Okay. Sometimes I'm just asking about multidimensional, multi-criteria methods. If our colleague choose just why and which. Okay. How did you choose the appraisal and the evaluation method? Okay.
We used the weighted sum because there were quantitative parameters, but with the definite software, we could also use other methods like Evamix and regime that also work with the qualitative parameters. So we could read in an integrated manner.
Okay, thank you. It's just for this because we know we managed definitely with various methods. It was just for this. Thank you very much. I think that we can pass to the next one. Okay. Now is Simona Panaro and Maria Cerreta. They introduce regenerating the landscape through the co-production of complex values. Is in presence? Sit. Okay. Simona Panaro is there.
Hi, I am online, sorry.
Hi, Simona. Okay.
Hi, Carmelo. Hello, everyone.
Okay, let me manage this strange place. Yeah.
Can I share my screen?
Yes, it's useful.
Just a second.
Okay, it's there. We get.
Can you see my screen?
Yes, yes, yes.
Oh, Carmelo, can I kindly ask you to mute? To mute, please.
Yeah,
your-
yes. Yeah, yes.
Thank you.
It's the last step.
Okay, sorry. Thank you. So just I start my presentation. Okay, so basically in this presentation, regenerating the landscape through the co-production of complex value, I will show you a case studies in the same context of the previous presentation, so the Cilento National Park in the south of Italy, where I worked jointly with Maria Cerreta in the development of a new methodological approach for the activation of a living lab that required to a new way to develop a governance city and landscape model. So basically, in my presentation, this presentation starts from the idea that basically to achieve the current Sustainable Development Goals agenda, we need to develop holistic political agenda. So basically, from the theoretical perspective, it's quite clear that the achievement of all these crucial goals are basically interlinked with each other and need an holistic perspective. But from the other hand, the policy and governance context, the current policy and governance context, it's quite fragmented. So basically, this context is still focused on topics policy, where the different governance level also have not a good communication each other. So basically, we need to innovate the policy and governance environment, also in terms of open this kind of context to the different actors in a more for a more inclusive perspective. Of course, this kind of issue require to manage a big and huge challenge, especially in terms of new way to communicate the complexity and uncertainty to a different kind of audience and stakeholders, but also have a research issue in terms of work in a more integrated approach, also to manage equality issue in terms of balance between different kind of interest in an environment in which the people have different power. So the Cilento National Park became the context in which we tested this new approach, and is quite interesting to note that in this context, the different kind of value linked to the huge heritage of the landscape was really crucial to explore and analyze. So basically, we are in a context in which there are big differences between the coastal area and the countryside and mountain zone. And the aims of this project was try to develop a more inclusive enhancement strategies of the heritage and the cultural, natural heritage, but also the material intangible heritage of this context that is quite important, as this park is recognized at UNESCO site from different perspective, from the heritage, the nature, but also the immaterial heritage like the Mediterranean diet. So we used an approach in which the value focus approach that starts from the idea basically that recognize and articulate different forms of value can be very useful to identify more appropriate decision and create better alternative in a complex context like this one of the national park of Cilento region. And we applied here a living lab approach that basically the living lab are open innovation environment in which the people are part of the co-creation process. So basically one of the key points of the living lab is that we need to activate not only public and private partnership, but also people. So the people need to be part of the new decision, new solution. And another key point in this context is that the new solution can be developed in a safe environment, but in a real life situation. So thanks to the testing, the co-design, and then the testing of new solution, new opportunity can become more tangible and also can be scaling up in the process. So in this project, we activate basically different kind of laboratory in the park, try to engage local community, especially in the countrysides and in the peripheral areas. That from one end was peripheral, but the research discovered that basically the most innovative way to promote the parks come from this context. And also we try to use this laboratory not only to explore with the people, the context and new opportunities to promote the huge heritage of this park, but also to create connection between the different community, the coastal community and the countryside community, in order to have a more integrated perspective in which the people become really the core of the strategies. And basically the starting from the real context and the real needs, we basically compare in each laboratory the inside perspective, basically the citizen perspective, with outsiders, so visitors, researchers, and other people that participate to this kind of laboratory. And during this interaction, of course, new knowledge a new idea were developed, and also this new perspective give us the opportunity to look in a more accurate way to the data, to analyze, and so help us to collect also objective and hard data in a more accurate way and very focused to the issue that comes out this kind of laboratory. So during this process, basically we develop a special dynamic context and analysis in order to identify the most, I think, innovative landscape enhancement approach that was already present in the park, but also identifying the abandoned landscape, a vulnerable area, in order to try to create a connection and a new opportunity for all the area of the park. Basically, work in this direction. We basically move beyond traditional governance model that you can see in the first quadrant, where the design, the decision, the production, and evaluation of the policy and the action are basically all inside of the agency and the public agency, we move from this kind of model to another model, more innovative model that you can see in the 4 quadrant, where the design, decision, production, and evaluation of action and policy are basically open to external actors and co-create with them. So for that, we're talking about co-governance, co-governing model, where each of his action are implemented with people outside of the public agency. So for that, we talk about co-design, co-decision, co-production, and co-evaluation. And basically, we trying in this project to set a methodology that look at the living lab context. From these sites, you can see the format model, that basically it's one of the most common living lab methodology used especially in the development of new product context, where basically the aim is try to develop a new product or services to be commercialized. Basically, we adopted the co-governing model. We integrate the co-governing model with the living lab methodology, and for that we designed a collaborative urban living lab methodology, cool methodology that you can see in this section of the screen, where basically each cycle of the living lab methodology was associated to one of the policy and governance strategies. So we have, for that we pass from the concept design of the living lab format to the co-design cycle, to the co-prototyping design of the living lab, to the co-production cycle. And then instead to have a final system design, we talk about a co-decision cycle in order to achieve a co-governance model, more open governance. And basically in each cycle, what is exactly different is the design stage, especially in the co-production and the co-decision, in which we don't design, we don't prototype a product, but basically action to activate with people in the co-production cycle. And in the co-decision cycle, we co-design with people rules system in order to scaling up the experience from one laboratory to another laboratory or a larger context. Also, we tested this methodology designed in the Cilento Labscape project in other 3 projects. So you can see how the scale of analysis was, this methodology was applied at the landscape scale, but also at the city and neighborhood scale for a different kind of situation. But in each case, what was relevant is the idea that working with people produce basically a new knowledge and try a way to organize this knowledge in order to improve in the process of change. Basically, the way to do things was really, really relevant. And looking more general, what we learned from these different kind of experience, and also to conclude, basically when we focus on the value and the complexity of value, we explore this kind of context directly with the people and in the real context, basically the solution that can be developed are quite different from the top-down or traditional ones. And also what is different here is also that the people can promote and also take a responsibility of the change. So become part of the cultural and landscape heritage evaluation, but also enhancement, developing a lower entropy model in which basically the physical transformation are reduced as much as possible in order to enhance the heritage in a more inclusive perspective. So thank you for your attention. Sorry, Carmelo, you are mute.
It's my tragedy. Okay, is there some question?
I have one question. And thank you for your presentation. And I respond that you cannot see me. I don't know if you can see me, but I hope you can.
Okay.
And I was wondering if, how, if they arise, you manage conflicts of power, of visions in this process of co-production, of alternative, of co-design. What do you have?
Okay. Basically, you sorry, just because the audio is not the best. So basically, just to understand if I understood your question, you asked me how we have managed power, different kind of power in this kind of context. This is the question. Sorry, Carmelo, you are mute again. So.
Now, can you hear?
It's a domino ready. It's quite difficult.
I was wondering if they arise, how do you manage conflicts of power of different perspectives, which can be, how to say, alternative?
Okay. Thanks for your question.
Can I just have a short reflection? The reflexive practitioner by Donald Shawn. There are some case study about conflict, about technical knowledge and groups.
Sure, I think
sure this is something about.
Okay, sure. I think this is a very hard point. So for that, at the beginning of my presentation, I talk about challenge. So it's not things that we can easy manage. I think the opportunity that the Living Lab and the Urban Living Lab approach give us was the idea that basically we don't start to consider everything together, but one of the core concept of the Living Lab that is we work a specific problem in a specific context with a specific community. So looking all this kind of restriction become more, I think, possible to engage the people that are really interested to the solution, really interested to innovate a specific aspect. So basically, this is a things that helps. It's not an overall process. It's a process that we activate for a specific challenge in a specific context, for a specific community or specific need. And this helps a lot. And in this case, also, the first challenge was have the trust of the people, no? And was a long process. This project, basically, we worked in this project for 2 years with this community. And also another things that I want to underline, it is not only the laboratory arrived at the same level. So basically we try to not press too much to the results, but we was really open to understand where was the really enable condition in order to develop something. So.
Okay, thank you. Some question? We are. Okay.
I will write.
Okay. Okay, thank you, Simona.
Thank you. Thank you.
The last but not the least, classical. Dario Esposito and Vito Santamato in presence. No? Okay. So the title of the paper is I'm getting really old with Assessment of Public Health Performance in Relation with Hospital Energy Demand, Socioeconomic Efficiency and Digital Services in Italian case study. Okay, so it's about sanitary. Is it?
Thank you. Can you hear me?
I hear you. Okay, now I stop with my microphone.
Perfect. Okay, perfect. Good morning to everyone. I'm Vito Santamato. I am PhD candidate in translational medicine and health system management at the University of Foggia. Today, I'm here to present a very interesting research study titled Assessment on Public Health Performance in Relation to Hospital Energy Demand, Socioeconomic Efficiency and Quality of Service, an Italian case study. This study was conducted in collaboration with Professor Dario Esposito from the Polytechnic University of Bari, Professors Tricase, Facilongo and Barengo from University of Foggia, and Professor Gianni Paguet from the University of Ioannina. The structure of the presentation will be divided in two main parts. Firstly, I will provide an overview of the study proposal and its application context. Secondly, I will present the variable used to construct the data set under study. And following that, I will explain the methodology employed and then shift the focus towards the obtained results and ensuing discussion. Okay, the study proposal is structured around three main objectives. First, the study investigated the relationship between energy management and hospital performance in the Italian public healthcare network. Second, we highlight the importance of developing guidelines for energy consumption management, prioritizing the acquisition of alternative or renewable energy, and designing, constructing, and managing hospital building with a focus on energy efficiency. Third, to lay the foundation for future follow-up that make important implication for hospital politicians and administrators working to balance quality of care with cost efficiency. The region of Apulia represents an extremely interesting context for studying hospital efficiency in terms of quality perceived by resident patients for several reasons. Firstly, the region has undergone a significant healthcare system reform in recent years, resulting in a complete reorganization of the entire system with the aim of improving efficiency and quality of healthcare service. Additionally, Apulia has a diverse population composed of a variety of heterogeneous groups, making it an ideal area for studying the relationship between quality of care and socio-economic difference. The regional health service in Apulia is represented by 6 aziende sanitarie locali. ASLs are public legal entity with autonomy in organizational, managerial, technical, administrative, patrimonial, and accounting matters, as well as entrepreneurial autonomy. In terms of hospital classification, in Apulia there are 5 second-level hospitals, 12 first-level hospitals, 2 scientific hospitalization care institutes, and 9 basic hospitals. A literature review was conducted to identify variables commonly used in study on hospital efficiency. The dataset used in this study was obtained from the National Health Service of the Ministry of Health and the National Outcome Plan on the National Agency of Regional Health Service. The 16 variables considered for the 28 public facilities in the Apulia region were divided into 2 groups. The first group include variable related hospital capacity, variable related to the hospital capacity to receive and treat patients, including the number of beds and wards. And human resource, then workforce, variable related to the number of doctors, nurses, and general hospital staff employed in the hospital. In the second group, we have included the outcome variable that express the hospital's performance in terms of hospital service. This variable refers to the number of patients treated and admitted to the hospitals. Active mobility, this variable assesses patient satisfaction with the care that received, translated as attractiveness of the hospital facility. Hospital outcomes, this variable assesses the quality of care provided to patients through quality indicator, such as mortality, hospital readmission, and surgical discharge. And last, day management, this variable refers to the length of the time a patient stays in the hospital. The combination of this factor will contribute to the overall perceived quality of care by patients. Then there are in dataset other 2 derivative variables. To calculate variable number 10, to calculate the infraregional active mobility in kilometer, we first calculate the interpolated distance between the capital city of the ASL, where the patients resides, and the city where the hospital providing the service is located. Subsequently, we added the total active hospitalization by ASL and by territorial area, respectively, for each hospital. Finally, we calculate the infraregional active mobility in kilometer by applying the following formula. Then, to calculate the cost of energy, we first calculate the ratio between the resident population in Apulia in 2020 and the total number of doctors in both public and private accredited hospitals for each ASL. We then multiplied this ratio by the number of doctors in each public hospital weighted by ASL. The resulting value for each facility, which is an expression of the population catchment area, was then multiplied by the per capita health energy cost of 21 and 45 cents for the Apulian population in the same year, 2020, as indicated by the National Agency for Regional Health Service. Then the methodological workflow is a graphical representation of the complex analysis applied in this study using data analysis and the machine learning tool with widget available in the Orange software. We choose Orange software for our analysis because it represents a robust data mining tool. Standardization allows all variables to be put on the same scale so that they can be compared fairly and accurately. The data set will be reduced in size by applying two distinct principal component analysis to the two groups of variable identified. We include an additional study variable, the per capita cost of medical electricity per Apulia resident in relation to the number of physicians in the year 2020. The new data set, which include the two identified principal components, the value of energy, will be subjected to training and testing by means of 10-fold cross-validation, and the linear regression will be used for this process. The learning algorithm will process the input data set and produce as output a prediction model capable of identifying the value of healthcare energy expenditure for given value of hospital organization and propensity to hospitalization of patients. Additionally, the ANOVA analysis confirmed the significant difference in energy consumption management among hospital groups. Standardized variable help improve the stability of PCA and avoid variable with high variance dominating the analysis. The original variable are transformed into two new variables that have a mean of 0 and standard deviation of 1. Standardizing the variable before PCA is an important step to ensure that the analysis is accurate and that variables are evaluated correctly based on their importance in the variation of the data. Then principal component analysis is a machine learning technique that reduces the complexity of a data set by transforming a set of original variables into a new set of linearly independent variables called principal component. The transformation of the data takes place in a new coordinate system where the new variables are orthogonal and arranged in order of importance. Then the data set will be reduced in size by applying to this PCA. The principal component for the first group will express hospital organization, while the principal component for the second group will express patient admission propensity, hospitalization propensity. Applying PCA to the first group perceiving almost 90% of the total variance with a minimal loss of information. The incidence of the individual original variable of the main components can be visualized by means of the data table widget. For applying a PCA to the second group of identified variable, perceiving almost 93% of the total variance. Then the linear regression is a statistical model that attempts to establish a linear relationship between a dependent variable target, and one more independent variable feature. Sustainability issues have become fundamental in all their various environmental, social, and economic facets. One of the main challenges to be overcome by hospital in this regard is energy management, based on environmental sustainability, which is used as a strategic means to achieve competitiveness and focuses on energy efficiency that include policy, strategy, and technology designed to reduce energy consumption, pollutant gas emission, and cost. Therefore, efficiency energy management in hospitals has the potential to improve energy efficiency on the one hand, and better management of public expenditure on health energy on the other. Then, based on this assumption, in this study, the per capita expenditure of the Apulian population is the calendar year 2020, distributed by hospital doctor, was identified as target variable. The linear regression widget is used to provide the prediction algorithm with the dataset containing the variable to be analyzed, and the performance of the model is evaluated using the test and score widget with a cross-validation tenfold. The results of the evaluation and the coefficient of the regression model for the 28 public hospitals in Apulia are described in slide. The results, the linear regression model has an MSE of 0.06 and RMSE of 0.2 and an MAE of 0.19, which indicated that the mean prediction error is relatively low. The R of 0.93 suggests that the model explains about 93% of the variance in the data, indicating a good level of fit. An increase of 1 unit in the variable hospital organization is associated with an increase of approximately 0.17 units in the target variable, and an increase of 1 unit in the variable hospitalization propensity is associated with an increase of about 0.19 units in the target variable. The dataset resulting from the analysis model proposing the study with the relevant predictive value generated by the linear regression for the 28 public hospital facility in the Apulia region is shown in slide. Then observing the results of linear regression represented graphically by means of the bar plot widget by ASL and by hospital facility denomination, it can be seen that the 5 regional public second level facility and 2 first level hospital of ASL Bari have outliers with respect to the overall distribution of the regression value. The results are confirmed by the scatter plot distributing the predictive value by different types of level. Then the ANOVA analysis applied to the same predictive regression values confirms a significant difference between the difference level of the 28 public hospitals. There is a difference between the macro group consists of basic first level and ICCSA hospitals compared to the second level hospital. Then in the study there are 3 limitations. First, a limited sample of hospital in 2020. Then the results were to the Apulian region only. And last, the study presented here as a limitation related to the calculation of active mobility variable, as privacy legislation restrict access to the residence data of each patients, such as the exact address. Active intra-regional mobility variable calculated based on an interpolated path between the patient city of origin and the hospital city of arrivals. In conclusion, there is no homogeneity in energy management among the public hospital, and the better management of human resource could be more effective in reducing energy costs than purchasing new equipment and expanding structures. The decision maker, health professional and planner must understand, plan and specify the provision of medical care in terms of hospital capacity, availability and supply. The study proposed a future best practice for healthcare company decision maker to have all the elements available, not only the company's own economic elements, but also to take into account exogenous socioeconomic factors. It is also attempt to outline an integrated and unified vision to formulate coherent assessments of the entire regional hospital network in order to support the public decision maker responsible for the regional healthcare system. Then the future follow-up, a planned follow-up is to integrate an analysis and representation system with GIS to study hospital mobility with actual distance traveled by patients, rather than relying on accessibility and variable related to the type and cost of transportations. This will provide a more accurate analysis of active healthcare mobility as an expression of the patient's choice of facility. Additionally, this approach will help to overcome the discrepancy between actual data availability for central hospitals and that may combine several sites or connected hospitals. They may be located in different and distance locations. Secondly, regarding the usefulness of the proposed analysis tool, we propose developing what-if scenario analysis to simulate management decision and resource allocation at the central regional level, at the local management level of individual hospital facility, to verify the impacts and possible opportunity for improvement. This will involve an analysis by medical discipline, a service offered rather than using aggregate data. Last, we also propose integrating the workflow proposed in this study with an analysis of data envelopment analysis efficiency applied to hospital structure using the main component identified as input and output. Thank you for your attention.
Thank you. I have a short question, just because if I remember, this is the result of a thesis.
Sorry, I can hear.
I'm just curious, but we have a really short time. I'm just curious about, maybe I saw something for a degree exam, something like that. Maybe there is some research and so on. How can you make some relevance of this the question of electricity, if you can have people that are guaranteed by a health system that can get pills that for 1 year have the cost of 306,000 euros. So I just mean that some health system is so complex that it's useful to make a general analysis, because each character is very different from the other, and so electricity is practical for the structure, but the health system is more relevant, and the chapter of the accountability is very complex. That is okay. One year of pills is more or less seven times more than electricity in the hospital, public hospital of Bari. That is. Thank you. Can you,
Thank you.
can you tell about something short, very short, because we have.
Yes. Then
It's very interesting anyway, but it's very a big debate about, I think.
Yes, is a complex and delicate subject matter. Taking into account the hypothetical balance between economical and social agents in order to achieve a DSS that supports the decision maker. Is the future objective of this study. And the cost of electricity is a part of a complex decision support system. Is more important because also to cost analysis, the electricity have a importance incidence in a balance, in a public balance.
Obviously, but there is something that is named the post-normal evaluation. That is outside the limitation that we know. Just this. Okay. Good luck, because anyway the field is very interesting. Is some way is very useful for the future. Okay.
Thank you.
Thank you.
Thank you.
Is there some question? Okay. Now I think that we can stop and have a nice lunch if it's possible, and I give. I make you free. Okay. Bye. Sì, grazie.
Bye, bye.
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 Come? La penna per scrivere? Aspetta, dove sta? Stava da qualche parte. Ma questa non è la capillare di architettura?
Di Linux, di economia.
Perché quello è il punto. Si chiama
Lo so cosa vuoi dire.
Yes, normalità della valutazione.
Io gli ho dato una mano sulla parte della
I don't know what happened.
spostamenti per valutare
Perché
le variabili
non
di
va?
spostamento.
Però siccome la sua
No.
l'azienda fa un bilancio e probabilmente le cure hanno più rilevanza
Però io non so
No, non va proprio.
Perché obiettivamente i privati sono più
Era buono.
Quindi è proprio un settore, non è un tema banale, guarda. Però ti dico che nonostante la tirata di orecchie, diciamo, secondo me va supportata.
collegati. Ok.